Hello everyone, welcome to the Rainbow Dash template tutorial. Here you will learn about the Rainbow Dash templates. This video will introduce how to implement the effect of the spotlight mechanism. Alright, let's get started. Enter the editor. Here we have already prepared a simple scene. Place a cylinder part in the scene. Adjust its position, size, transparency, and uncheck its gravity and collision properties. In the Game Resources view, change its name. Click the Add button to the right of the part name to add an effect. Use the prepared spotlight effect. This completes the building of the spotlight mechanism. You can design different styles of mechanisms effect according to your game scenes. In the template, the spotlight mechanism will move randomly within the region. When the player enters the spotlight range, the player's progress will increase, and when the progress reaches 100%, the player will pass the level. Let's start by implementing the logic for the spotlight movement. Click Game Settings, select Triggers and Scripts, and open Server Script Management. Create a new server script and rename it to Spotlight. Open the script and first define a module, Spotlight. Then, define some variables. The part variable is used to store the spotlight mechanism obtained from the scene. The random position region variable is the range of area, where the spotlight moves randomly, and requires a minimum and a maximum coordinate position to be specified. The speed variable is the speed at which the spotlight moves. The target position variable is the target position of each random move. The interval position variable is the unit distance vector per move. The timer variable is used to store the created timer variables. After defining the variables, let's declare a startup function that can be called externally, and pass a parameter named map to the function. The map parameter represents the map of the game, and we can use the find_for_child function under the root property of this parameter to get the parts with the specified name. For example, here we use this function to get the spotlight. The editor provides a tool class, lib, where we can use the random position and region function to get a random position in a specified region. This allows us to initialize the target position variable by passing in the random position region variable. As for the interval position variable, we need to get the difference between the target position and the current position of the spotlight. Normalize the difference and multiply it by the set speed to get the unit distance vector of each spotlight movement. Next, we turn on a timer that executes the specified callback function once per frame. We need to implement the logic for spotlight movement in this callback function. More API content can be found in the official website documentation. In order to move the spotlight from the current position to the target position, we let the spotlight increase the unit distance vector once per frame from the current position. In this way, the spotlight will slowly move toward the target location. The speed of movement can be adjusted by the speed variable. We can use the distance function in the vector3 class to get the distance between the spotlight and the target position. When the distance between the two is less than a certain number, we consider that the spotlight has reached the target position. Otherwise, the spotlight should continue to move to the target position. When the spotlight moves to the target position, it has to randomize the next target position, and update the unit distance vector for each move, so that the spotlight will continue to move towards the new target position. Here, we just need to make a copy of the code that gets the target distance, and the unit distance vector in the startup function. Adjust the code and open the server's main script. Use the require keyword to load the Spotlight module. Use the getStaticMap function of the world class to get the current map. To avoid that the game object from not being fully loaded when the players enter the game, causing us to be unable to obtain the Spotlight parts, we can start a timer and wait for 160 frames before calling the Spotlight module startup function. After completing the code, go back to the editor, run the game, and look at the results. You can see that we have successfully achieved the effect of random movement for the Spotlight. In the template, in addition to the random movement effect of the Spotlight mechanism, it also has to continuously record the player's progress within the range of the Spotlight. There are two parts of logic involved here, calculating the progress and displaying the progress. Let's complete the logic for calculating progress first. We can determine whether a player meets the condition of being continuously within the Spotlight by comparing the time the player has been in the region with the time the game has passed. For example, if we determine that the player has been in the Spotlight range for more than 1 second, then we can increase the player's progress by 1. To implement such logic, we need to define some variables first. The touch player's variable is used to store the player's playtime when the player enters the Spotlight. We use the player's object ID as key, and the playtime as value. The progress table variable is used to store the player's progress. We use the player's object ID as the key, and the progress as the value. The total progress variable is the total amount of progress the player needs to complete to pass the level. The min stay time variable is the minimum time the player has to stay in the Spotlight. As long as it is greater than this time, the player's progress can be increased. The detail progress variable is the value of each increment of progress. Next, we define a local function, and call it in the startup function. This function is used to handle the collision logic between the player and the Spotlight. In fact, when a player enters the Spotlight, it means that there is a collision between the player and the Spotlight parts. In the entity triggers, there are two triggers for handling collisions between entity and part: entity touch part begin, and entity touch part end. Entity touch part begin indicates the start of a collision between an entity and a part, which can be used to indicate that the player has entered the Spotlight range. Entity touch part end means that the collision between the entity and the part is over, and can be used to indicate that the player has left the Spotlight range. To register a collision trigger, you can use the register handler function in the trigger class. It has 3 parameters. The first parameter is the configuration information of the object that activated the trigger. Here we get the player's configuration information through the entity.getConfig function. The second parameter is the trigger name. Here we use the trigger when the entity starts touching the part. The third parameter is the callback function to be executed after the trigger is activated. This callback function has 1 parameter. The object1 field of this parameter indicates the object that activated the trigger, which in this case is the player. The part field of this parameter indicates the part that collided with the player. When the player touches the Spotlight parts, use touch players to record the game time at this time. The game time can be obtained through the time property in the game class. Since touch players requires a data structure in the form of key-value pairs, you can use the object ID property of the obtained player entity as the key. When the player leaves the Spotlight range, we have to empty the data saved in touch players, i.e., make it equal to nil. This is to prevent the continued calculation of players' progress. when the player leaves the spotlight range. Now that you have the time when the player entered the spotlight range, you can calculate the difference between the current game time and the player's entry time per frame. If the difference is greater than the min stay time variable, then the progress can be added to the corresponding player. Define a local function setProgress, which is used to handle the logic of the player's progress. First, get the current game time. Then iterate through the touch players table, and get the corresponding key and value. Where the key is the player's object ID, and value is the time when the player entered the spotlight. We subtract the two timings to determine if the difference is greater than the minimum stay length. If this condition is met, the player's progress can be increased. Before we can increase a player's progress, we need to get the player entity and the progress that player has. Use the current world property of the world class to get the current map, and then use the getObject function to get the player entity. This function takes the ID of the player entity as a parameter. Here we pass an object ID. For the progress owned by the player, we can get it in the progress table by using the object ID as an index. In order to prevent players from quitting or dropping out in the middle of the line, we need to determine if the player is empty first. If the player exists, then it is possible to set the player's progress. If the player's progress is not nil, then add the progress to detail progress and save as the player's latest progress. Otherwise, the player's progress is detailed progress, which means that the player's progress has just started to increase. After the player progress setting is completed, the player's entry time into the spotlight needs to be modified to the current game time to prepare for the next judgment. If the player does not exist, then the player's progress data needs to be cleared. Lastly, add a log that outputs the player's progress values. Tweak the code a bit and put the setProgress function in the timer's callback function. Then go back to the editor, run the game, and look at the output log. You can see that the player's progress increases when the player is in range of the spotlight. To display the player's current progress, you need to use the UI. Create a UI file, and you will find both a layout file and a Lua script file. The layout file is the editor UI file, and the Lua file is the script file for that UI binding. Double-click to open the layout file, drag a text widget onto the scene view, and adjust its position, font size, and other properties. After the UI is created, open the Spotlight script, and find the place where the progress value log is at output. Because the UI is client content, and the Spotlight script is server content. To make the client UI display the data saved in the server script, you need to send the data from the server script to the client. So how do you send the data? The editor provides the package handlers class, which can be used in the server script to send data to the specified client, using the send-to-client function. This function has three parameters. The first parameter is the specified client, i.e., the specified player entity object. The second parameter is the name of the message to be sent. The sender and receiver of the message must have the same message name in order to successfully dock. The third parameter is the data to be sent. The data type is table. When the player's progress is less than the total progress to pass the level, we send the percentage of the player's progress out of the total progress to pass the level as data to the client of the specified player. When the player's progress is not less than the total progress to pass the level, we will send 100% as data to the client of the specified player. You can also design the logic of the player after passing the level here according to the content of your own game. After completing the code, go back to the editor and open the main script in the client script management interface. In this script, we are going to open the UI we just created. First, define a variable that holds the returned window object when the UI interface is opened. To ensure that the relevant UI resources have been initialized, when the UI window is opened, we need to bind the event for client initialization. The getEvent function in the event class can get the specified event. Here, we pass in the string onClientInitializeDone to get the event when the initialization of the client is complete. For more information about the events, you can find them in the official API documentation. Once you get the event object, you need to call its bind function to bind a callback function. This also means that the bound callback function will be called when the initialization on the client is complete. We can open the specified UI window in this callback function. To open the specified UI window, use the createGUI function in the UI class. The parameter is the path to the specified UI in the assets view. In addition, you need to add the obtainUI window object to the root node of UI, otherwise the openUI window will not be displayed on the screen. After completing the code, go back to the editor and open the script file for the UI. Call the getUIByName function with the self keyword to get the text widget you just created. Define a local function for the initialization of the UI. Define another externally callable function to set the player's progress data, which takes one parameter to receive the player's progress data. We can set the content of the text widget by calling the text property of the text widget. Back to the main script on the client. We use the receive function of package handlers to receive messages from the server. This function has two parameters. The first parameter is the name of the message, which needs to be consistent with the name of the message sent by the server. The second parameter is a callback function that will be executed when the client receives the message. This function has two parameters, which are the data sent from the server and the specified player. In the message callback function, we call the function used to set the player's progress in the UI script file via the variable created earlier to hold the UI window object. The parameter is the data we receive. This completes our logic for displaying the player's progress. Save the code, go back to the editor and see the result. As you can see, the player's progress begins to increase as the player comes within range of the spotlight. This is all the content of this video. I hope this content can help you make better games. To learn more about the content related to the Rainbow Dash template, you can leave a comment below the video, or post it on the official forum. See you in the next video.